Hello everyone. In today's session, we are going to see how to control volume of a PC using finger gesture. So for this, we are going to use Jupyter Notebook. Okay, for this, we are going to use MediaPipe and PyCon. This Jupyter Notebook demonstrates how to use the MediaPipe library for hand tracking and the PyCon library to control the system volume based on finger gestures. So basically, this notebook captures video from the webcam, detects hand landmarks, and adjusts the system volume using finger distance. So before running this code, you have to make sure that you have this required libraries installed. So first library that we need is MediaPipe, Pica. Let me write it for you. MediaPipe, then Pica, NumPy. Open CV. This is for displaying images in Jupyter Notebook. And how to install these libraries? For this, you have to go to your command prompt, or even you can do it from here itself. So you're going to use pip install. If it is for MediaPipe, you have to use this code, pip install MediaPipe, Pica, and OpenCV Python headless, and NumPy. After installing these libraries, you have to import these libraries. So this is the code for that. We are going to import all these required libraries. We import CV2, and this CV2 is OpenCV for image processing. This MediaPipe for hand tracking and landmark detection. NumPy, import NumPy as NP. This is for numerical operations. And we have import. We are going to import this library under from math. What is this hypot? Hypot stands for hypotenuse. This is for calculating the hypotenuse between 2 points, that is the Euclidean distance. And the C types and COM types. These are for interfacing with the Windows Core Audio API to control the system volumes. Okay. Now these lines. Here we are initializing MediaPipe for hand tracking. MP hands.hands of this is for creating a hands object for hand tracking. Okay, this is the object here. And mp.solutions, this line, dot drawing underscore utils is a utility for drawing landmark on images. And the next thing, we are going to initialize the audio interface to control system volume. Audio utilities get speakers, that is to get the default audio playback device, and activate is to activate the audio endpoint interface. Get volume range is to get the range of volume levels. And the other things, casting is for casting the interface to an audio endpoint volume object. Can you see? Audio endpoint volume. This is an object. So casting the interface to this object. and volume min and max. Here, the minimum and maximum volume values in the range. Next, we are going to initialize the webcam capture using OpenCV. So this is the line cap is equal to cv2 dot video capture of 0. This is to create a video capture object to access the default webcam, that is index of 0. Then we enter the main loop. To continuously process video frames from the webcam. This cap.readoff, it captures a frame from the webcam. And image underscore RGB, this is to convert the BGR image to RGB, because that is only suitable for media pipe processing. Here, hands dot processing of image underscore RGB. This is to process this RGB image using media pipe hands to detect hand landmarks. So to use these things only, we need media pipe. If hand landmarks are detected in these images, we have to iterate through each hand to gather landmarks. So for that, we are using these steps. Can you see here? It's okay if you don't understand each and everything, just get the overall picture of this. So here we are checking here. So here we are checking if there are detected hand landmarks. If yes, iterate through each detected hand landmark, and H stands for height, W stands for width of the image, and CX, CY is to calculate pixel positions using landmark coordinates. Then LM list is to store landmark informations. Then we are going to draw hand landmarks on the image using that MP draw. And then inside this loop, we are checking if there are hand landmarks stored in LM underscore list, which is detected in the previous step. This X1, Y1, X2, Y2, these are for extracting the pixel coordinates of the thumb tip and the index fingertip. And the circle of is to draw circles at the thumb and index fingertips on the image. And cv2.line off is to draw a line connecting thumb and index fingertips. So here, length is equal to hypot of this line is to calculate the Euclidean distance between the thumb and index fingertips using this hypot of function. After this, we are going to use this numpy function. This is to map the calculated distance to the range of system. So what we are doing is basically this code processes webcam video, detects hand landmarks using media pipe, calculates finger distances first, and then it maps this distance to volume levels and adjusts our system volume accordingly. So for that, we need to calculate both the distance, right? And np.inter of function, this is to map the calculated distance to the system volume state. Okay. Then set master volume level, it is to adjust the system volume based on the mapped value. And finally, we are displaying. We have to display the image with hand landmarks and distance using the distance line using cv2.anshow. And this wait key of function is to wait for a key press for 1 million second and check if it's if it is the key Q. If the letter Q is pressed, break out of the loop. After the loop ends, we release the webcam capture object and close all OpenCV videos.